In this video we're gonna talk about some applications on sigma notation. So before we start with that, I'm gonna just give two rules and remind you with one rule we did before. So you know that when we have sigma from I equals 1 to, let's say, 5 of a number, so this number is not actually related to I directly. So in this case we can directly multiply 5 and 2, get the answer as 10 without using calculator. So in general this rule is sigma from I equals 1 to n of a constant number k. So whenever I see here a number that does not relate to the index we see here, directly I can do the following. So these two numbers I can multiply them and I get it as n multiplied by k. So this is one rule. I will write it here again. It's n times k. Now another rule which is very helpful, sigma of k equals 1 to n. So now my index is k of k by itself. So here basically I'm doing 1 plus 2 plus 3 plus 4 plus 5 till we reach n, whatever n is. So basically I'm adding the first n natural numbers, and this has a rule which is n times n plus 1 over 2. Now if I look at this one and I tell you sigma from k equals 1 to 10 of k, so here and here we have the same variable. In this case, instead of doing 1 plus 2 plus till we reach 10, we can apply the rule directly and do 10 multiplied by 10 plus 1 over 2, and in this case we get 10 multiplied by 11 over 2, which is 110 divided by 2, and the answer is 55. Alright, another rule which is also very helpful, if k starts from 1 to n of k squared. So basically here I'm doing 1 squared plus 2 squared plus 3 squared. So this is the expansion of this rule till we reach n squared. So this is basically the sum of the perfect squares, if you know them: 1, 4, 9, and so on. Instead of writing it in this way, this has a very nice rule, which is n multiplied by n plus 1 multiplied by 2n plus 1 over 6. So you can take this as a rule and apply it whenever you don't have calculator. For example, sigma from k equals 1 to 10 of k squared. If I don't have calculator and I want to calculate this one, so I use the n, which is 10 in this case. So 10 multiplied by 10 plus 1 multiplied by 2 times 10 plus 1 over 6. Now I have 10 multiplied by 11 multiplied by 20 plus 1, which is 21 over 6. Now remember, I don't have calculator, so it's better to check if we can simplify. If I divide 6 by 2, I will get 3, and if I divide the 10 by 2, I will get 5. So divide 6 and 10 both by 2, you get 3 and 5. Then I look at 21 and 3. I can notice that we can divide by 3 here, we get 1. Divide 21 by 3, we get 7. And we are left with 5 multiplied by 11 multiplied by 7 on top over 1. So no need to write the denominator 1. 5 multiplied by 11 is 55 multiplied by 7. Now we can do the 55 times 7 on the side and get our final answer. So 7 multiplied by 5 is 35. Again, 7 times 5 is 35. Add the 3 and we get 38. So my answer here will be 385. Alright, now I'm gonna do some examples. So if you are given in a question the sigma of AK and K here from 1 to 10, and I tell you the answer of that is 30, and the question is, what is the value of sigma from K equals 1 to 10 of 3AK? So again, we go back to the rules. I know that sigma from K equals 1 to 10 of 3AK, I note that there is a constant number multiplied, and as we said before, we are allowed to take it outside. So it will be 3 multiplied by sigma from K equals 1 to 10 of AK. Now, do I have this one? Yes, it's given to us in the question as 30. So my answer will be 3 multiplied by 30, and the answer will be 90. Another example. If you're given sigma of t equals 1 to 3 of t multiplied by t plus 2, and you don't have calculator for that, then I'll start replacing. So 1 plus 2, this is our first term, by replacing t by 1, plus, after 1 we have 2, so 2 plus 2, till I reach the n which is on top, 3. So I write 3 plus 2, and I evaluate. 1 plus 2, we know it's 3, so 1 multiplied by 3, then 2 plus 2 is 4, then 3 plus 2 is 5, and I will calculate this. 1 multiplied by 3, it's a 3. 2 multiplied by 4 is 8. 3 multiplied by 5, it's equal to 15. And we add 3 plus 8 is 11. 11 plus 15, and my answer will be 26 without calculator. One more example. If they're telling us which expression represents the following: k equals 1 to 6 of k exponent 3. So they don't want you to evaluate and get the final answer, just they want the expression. In this case, simply instead of k the first time 1, then 2, then 3, then 4, then 5, till I reach 6. That's it. Alright, the last example in this video will be about simplifying an expression in this way. So k from 1 to 7 of maybe k squared plus 2k minus 1, and you need to simplify this without the calculator. Now I go back and check the two rules here. So sigma from k equals 1 to n of k, I need to remember it's n multiplied by n plus 1 over 2. The other rule, sigma from k equals 1 to n of k squared, is equal to n into n plus 1 into 2n plus 1 over 6. So let's try to use these rules and some properties of sigma to finalize our answer. The first thing I notice that we have addition and we have subtraction, so we are allowed to separate this sigma notation. So we write sigma of k squared alone from 1 to 7 plus sigma of 2k from k equals 1 to 7 minus sigma of 1 from k equals 1 to 7. Now this 2 is multiplied, so we are allowed to take it outside. So I'm gonna just rewrite it one more time. I'm writing in details, but if you can notice that while separating, you can write the 2 directly outside. So from k equals 1 to 7, and this is the last one. Alright, now sigma of k squared, we know it's gonna be n multiplied by n plus 1 multiplied by 2n plus 1. N in this case is 7, so I know it's gonna be 7 plus 1 multiplied by 2n plus 1, so 2 times 7 plus 1 over 6 plus 2 multiplied with the sigma of k from 1 to n is just n multiplied by n plus 1 over 2, and n in this case is 7, so we write 7 plus 1 over 2. And for the last one, whenever I don't see the index here, then directly we are allowed to multiply these 2. So this will be 7 multiplied by 1. Let's proceed with this. So I have 7 multiplied by 8 multiplied by 2 times 7 is 14 plus 1, which is 15 over 6. Here, if you notice that we have 2 and 2, they cancel out, so you get 7 times 8 minus 7 times 1, which is only 7, equals. Now 6 and 8 both can be simplified by 2, so 6 divided by 2 will be 3, and 8 divided by 2 will be 4. If you can do more, 3 divided by 3 is 1, 15 divided by 3 is 5. So I can notice that the denominator is 1, no need to write it anymore, and we get on top 7 times 4 times 5 is 20. Now 7 times 8, we know it's 56, and we have minus 7. Now 7 times 2 will be 14. We add the 0 because we have 20, so it will be 140 plus 56 minus 7. Now simplifying this answer, 140 plus 56 will be 196 minus 7, and the answer will be 189.